All right, we're going to try this redo. Try to give it a shot here. So yeah, Wednesday, all the videos I recorded, the sound was messed up on them. There was some kind of interference. I really don't know what caused it. It just seems to happen every time I have some good plans laid out, you know. So a couple things that we talked about in class that I want to go back over. One, we had some folks mention that they got confused on the test questions. Remember the test questions, I made those to where they were pretty much the same as the ones that you saw in the labs. So as long as you use the financial calculator, Auto Trader, or one of the other websites that we had, should have been okay. Now we have ran into some folks that are using Apple products not being able to use our resources. Only thing I can tell you with that, you know, Tri-County is a largely Windows and Microsoft campus, so if you're using an Apple product and it's not working, you might want to try to find a Windows computer or a Chromebook or something that will. I know that with MacBooks, for instance, Auto Trader automatically erases the values that you put into the website. Also, remember with the financial calculator, whenever you open it up at the top, it's going to come up with a little warning bar that basically says, did you mean to open this? You did, so you have to click Enable Editing, otherwise nothing is going to happen in that spreadsheet. So just something else to be aware of. All right, so I'm going to walk you back through our statistics lesson from yesterday. So real quick, a couple of things. In the book for Part 1 statistics out of our statistics and probability section, so for Part 1, you're going to be in section 6A, 6B, and 5E. We're going to be hopping around. We're going to cover 6A and 6B first, then we'll come back to 5E later. All right. In 6A, we're looking at the three things that we're most familiar with, mean, median, and mode. You've seen those before. 6B, box plots and 5-number summary. We'll go over that too, and then we'll finish out with scatter plots going back in 5E. So let's open up the notes page that I've got in Moodle here. Right now it'll be popping up in the bottom right corner until I get it full screen. All right, so these are handwritten notes. There's a couple little boo-boos I got to fix on here. But for the most part, you know, everything's pretty much in order. I'm trying to find where full screen is in this web-based PDF thing. It's not showing. Oh well, let's just do it this way then. Okay. So as I already mentioned, the first couple things that we're going to be looking at are mean, median, and mode. All right. So we're starting off with statistics first. Okay. So we'll look at probability next week. Some aspects of statistics that we're going to look at. Let's start with the first three that we're talking about, mean, median, and mode. Mean, we know is average. The way that you get the average is you take the sum of the values and you divide it by the number of values. So the sum of the values is, you know, you take them all, you add them up, you get that number, and you divide by how many you had. So if you're getting the sum of 12 numbers, you put 12 on the bottom, divide by that. If you're getting the sum of 7 numbers, you put 7 on the bottom and divide by that. So seems to be the part that most people forget, is what number you have to divide by. You take the set that you have and you divide by how many were in that set. We've got these things called outliers that we're going to talk about here in a minute. With outliers affect the average a great deal, but they don't affect the median or the mode. So outliers can also be called extremes. All right, and the reason why outliers affect the mean is because the mean takes into consideration every single number in the set, whereas something like median does not. All right. Median does not take into account every number in the set. What you do with the median is, before you find it, You take all your numbers, you put them in order, okay, and then you find the number that's in the middle. So with the number that's in the middle, if it's an odd set, it's going to be sitting right in the middle. If it's an even set, you have to average the two in the middle and figure out what it is. Now I put here that it's barely affected by outliers, if at all. You can replace that and say that it is not affected by outliers at all. All right, because outliers aren't going to mess with it any. Same thing with mode. All right, mode is the most occurring value in the set. If no value repeats, there is no mode. You don't say that the mode is 0, because then you're telling someone that the number that popped up the most is 0. Mode comes in handy if you are looking at, like if you run a store and you're selling an item and you want to know which item is selling more than the rest of them, that'd be your mode. There are times when mean and median, you have to look at those and see which one of those is the better representation of your numbers. And we'll talk about that here in just a second. All right, so getting back to outliers. All right, so outliers, they're also called extremes. So extremes are values that are much higher or much lower than the majority. They greatly affect the mean, and I know I wrote barely affects the median and mode if at all, but they don't. They don't affect those numbers at all. I just misspoke. All right, so looking over here at the board. All right, so we're going to talk about the difference between a mean versus a median. All right, so I'm going to hide the notes just for a second. I'll pop them back up here in just a little bit. You can keep them up on your screen. Okay, so we've got this problem that was actually in our 110 class a couple of days ago. And the question was, somebody is looking at the salaries, the typical salary of 10 people at a company. All right, and here they are. And I went ahead and put them in order for you from least to greatest. You don't have to have them in order from least to greatest for mean, but you do for the other two numbers. So it helps if you just kind of go ahead and do that. All right, so the mean. All right, so let's find the mean. Okay, so with the mean, you're going to take all 10 of these numbers and add them up. Now, if you notice, we do have an outlier out here on the end that could potentially skew our data or pull it too far in one direction. So 1100 plus 1200 plus 1300 plus 1400 plus 1500 plus 1600 plus 1650 plus 1700 plus 2500 plus 6500. Now, if you're in the morning section, yes, these are different numbers than we used in your notes. Just be aware of that. All right, so you add all those numbers up, and you come out with a sum of 20,450. Well, that gets divided by 10, so your mean is 2,045. So what the mean is saying is that the typical employee at this company makes over $2,000 a month. But is that the case? Because look, we've got 1, 2, 3, 4, 5, 6, 7, 8 people that make less than $2,000 a month, and only 2 of them that do. So in this case, the mean is not really an accurate representation of what everybody's doing at this company. So let's see how the median matches up with it then. All right, median's a lot easier to find. You've already got them in order, so you just have to find the 2 numbers in the middle. The reason why you have to find the 2 numbers in the middle, because you have 10 numbers and that's even. 1, 2, 3, 4, 5, 6. So here are 5 and 6. So you're going to average these 2 numbers together. 1,500 plus 1,600 divided by 2. And yes, you're dividing by 2 this time because you only used 2 numbers. So this is going to come out to be 1,550. I'm just going to kind of shorten that up. So then look at it and say, well, how many people are making at least 1,550 or around that much? So half of them are making at least 1550, and one of them is almost there. So the 1550 is a better representation of what the typical person is making at this company. The 6500, that's probably someone that's been there a really long time, or maybe they have an advanced degree. You never know. Okay, so that is how sometimes you have to be careful and say, is the mean a better indicator of this, or is the median a better indicator of this? I've got a spreadsheet that I use for fantasy football, and I look at both numbers, the mean and the median in this. Sometimes, you know, a player could have a really good game or a really bad game. It'll mess their average up, but their median will still kind of be okay. So just something to think about there. All right, so there's mean, median, and mode, and there how the outliers affect it. All right, so let's go back to the notes. Okay, so this example here came out of the textbook. I'm going to put this on the big screen for a minute here. All right, so this example came out of the textbook. All right, this is number 13 off of page 371. All right, so what it was, it said a person took a Webster's dictionary and opened it up to a random page 10 times and counted how many definitions there were on each page. These are the numbers that they got. So they want to find the mean, median, and mode for all three of these. So first thing you do, put them in order from least to greatest. All right. So what I usually do is I usually mark them out as I go, but what I did was I underlined them. So 34, there's 34, 36, there's 36, and so on all the way up to 79. And then I double checked and made sure that I had 10 numbers accounted for on both sets. That way I didn't miss one. All right. So then first we do the mean. All right. Because the mean takes the longest to do. You're just going to add all 10 of them up, divide by 10. You got 533 divided by 10 for a mean of 53.3. All right. Next you do the median. Because with the median, you just look at the two in the middle, and then if it's even, if it's not even, you don't have to look at the two in the middle. You're going to see some odd number sets, but I didn't put those up here because they're easy. You just look at the number in the middle. So for median, you've got 51 and 53 that I circled there, and that means that the median is going to be 52. And there is no mode. There was no repeating number here. All right. So that one was pretty straightforward. All right. I'm going to stop the video here and check the sound, and then we'll come back with 5 number summary and box plots. All right. Looks like this is about as good as the sound's going to get. I think it's just picking up the air conditioner in the background. All right. So, box plots with a 5 number summary. So a box plot used to be called a box and whisker plot. The ones that we're going to make today, they still have whiskers. But in order to make a box and whisker plot, you have to have something called the 5 number summary. And what the 5 number summary is you've taken that set of data and you're going to be identifying specific parts of it. So first, let's say in green, we've got the lowest value and the highest value. The lowest value in some cases is called the lower extreme, and the highest value is sometimes called the upper extreme. So those two numbers are basically, after you put them in order, your first number and your last number. So they're pretty easy to find. They're actually the easiest ones to find. Okay. In red, we talk about the next two, the lower quartile and the upper quartile. A quartile, if you look here down below this, since it's a word that we're not used to, a quartile is a median of the upper and lower halves of your data after they were separated by the median of the whole set. So if you look back on the board, the whiteboard that is, so the 1550 was the median of our entire set. And you see how it split the data into two halves that have 5 numbers each. So with those two, that's what we have to use to get our quartiles. All right, so we'll do that in just a bit. And then of course, our median on the board over there is already in blue, so we know where it's at. All right, so a little piece of extra info here down at the bottom. The 5-number summary is found after the data set is ordered least to greatest and before building the box plot. So you need to make sure that you know that. You cannot make the box plot without the 5-number summary, and you can't get the 5-number summary unless you've got everything in order. So we got green and red here. All right. So in green, we've got our lower extreme and our upper extreme. All right. So I'm going to just circle those. All right. So 6,500 is our upper extreme or our highest value. And then 1,100 is our lower extreme or our lowest value. Then we've got the quartiles. All right. So the quartiles are the medians of the lower and upper half. So first, let's get our lower quartile. So 1, 2, 3, 4, 5 in the lower half. So we've got 5 numbers in the lower half, which means that we're going to have one number exactly in the middle. So there is our lower quartile. And then we've got to do the same thing for the upper half. And then there's our upper quartile. All right. So let's draw this out in a box plot. All right, we've got our 5-number summary. We've got our median, we've got our extremes, and we've got our quartiles. All right. So make yourself a number line. There's not always going to be one provided. You can partition it up however you want to. What I did with this one was I started at 1,000 and I went up by 500 each time until I got all the way up to my upper extreme of 6,500. You can go past your upper extreme if you want to. You don't have to. All right, so mark your 5 numbers as points on the number line. So first we got 1,100. So 1,100 is going to be about right there. Then we've got 1,300. So 1,300 is going to be almost to 1,500. Maybe not that close, but oh well. So 1,550 is our median. So that's going to be a little bit past 1,500. Our upper quartile is 1,700. So that's going to be somewhat between 1,500 and 2,000. Looks like a 7,000, 2,000. And then our upper extreme, of course, is 6,500 all the way out here on the end. Okay, so how do you draw the box plot? Well, I'm going to show you. So let's go back to our handwritten notes and skip ahead just a bit because there are steps down at the bottom that walk you through how to do this. Because what I did was I went ahead and made one for the other book problem, but we'll go over that in a minute. So down here at the bottom, the first asterisk, the box goes around the quartiles, okay? The box goes around the quartiles. So we did our quartiles in red. So I'm going to do our box in red. Oh, forgot to switch the cameras just a second. Okay. Yeah. So we did our box in red. All right, next, the median gets a line through it. All right, so the median gets a line through it. Now, of course, you don't have to do these in different colors. I'm just doing this to give you a better idea where everything's at. And then the extremes get connected with whiskers. Okay, so the whiskers connect to your extremes or your outliers. All right. Now, the textbook for the extremes and the outliers, they do this. and you can do this if you want to, you don't have to, but they draw a line through the extremes to make it look like a start and stop point. All right, so there's that. All right, so there's your box and whisker plot for the salaries at this company. All right, so there you go. All right, so let's look some more at our other number set, going back to the dictionary problem. Okay, so going back to this dictionary problem, we can do the 5-number summary for this information as well. So we have already found the median from the previous page, right? So the median's 52. All right. Then we can go ahead and identify our upper and lower extremes. So our lower extreme is 34. Our upper extreme is 79. You can call them extremes. You can call them low value, high value. Doesn't matter to me. Then our quartiles were found by, we've got our halves here. So here is our lower quartile, and here is our upper quartile of 39 and 63. All right. So mark everything on the line then. All right. So we've got our lower extreme and we've got our upper extreme. Then we've got our quartiles. So there's our lower quartile, there's our upper quartile, and then we've got our median, which is here. Okay, so then do your box. So first, the box, oops, wrong color. It was green yesterday. So the box goes around the quartiles. The median gets a line through it. And then the extremes, or the outliers, are connected with whiskers. Okay. Now to make the number line, I just kind of looked at what I had. I knew I had a lower extreme in the low 30s and an upper extreme in the high 70s. So I just went from 30 to 80, and I just went up by 5s every time. You don't have to do it that way. You can do it however you want to. That is, of course, if a number line is never provided to you. Now, on your assignment, you're not going to be asked to draw your own box and whisker plot. Rather, you're going to be given a set of numbers, asked to find the 5-number summary, and then see which scatter plot matches the best. So you may want to draw one on paper and then see which one comes out closest to what you have. All right, let's finish out with scatter plots because they're pretty simple. All right, scatter plots. Scatter plots are graphs that represent the values of 2 variables. So what you've got is you have 2 variables being measured against each other, and you're seeing if they have any effect on each other. So first, let's talk about a positive correlation or positive relationship or a positive scatter plot, okay? So in a positive scatter plot, what happens is as the x variable increases, the y variable increases. So remember your coordinate plane, you got the 4 quadrants, you got x and y. X is horizontal, y is vertical, right? Okay, so what's happening is your x values are increasing. Now, I don't mean along the axis. I mean like your data, okay? And then your y values are doing the same thing. So what that does is it makes a scatter plot that goes like this, okay? So a positive scatter plot goes up to the right, all right? Goes up to the right. Now the book goes into detail about strong positive, strong negative, weak positive, weak negative. We're not going to spend time on that. We're just looking at, is it positive, is it negative, yes or no. So speaking of a negative scatter plot, all right, so let's look at a negative one. All right, so the only difference in a negative scatter plot is that the y is going to be doing something different. In a negative scatter plot, I'm starting to run out of room here, so let me just fix that. Okay. So in a negative scatter plot, x is still increasing. The reason why x is always increasing on these is because x most of the time is a unit of time. So like years, days, months, weeks, hours, stuff like that. Okay? So as your data values on your x-axis go up, the data values on your y-axis go down. So what it does is it makes a graph that looks like this. All right? Goes down to the right. Now think of it in terms of ordered pairs. Okay? Looking at the positive scatter plot, you've got ordered pairs there like 1, 1. Oops. That's in red. That's going to mess that up. So you got ordered pairs like 1, 1, 2, 2, 3, 3, 4, 4. Going up to the right. As the x goes up, 1, 2, 3, 4, the y goes up, 1, 2, 3, 4. Whereas with the negative one, you've got ordered pairs like 1, 10, 2, 9, 3, 8, 4, 7. As the x's go up, 1, 2, 3, 4, the y's are going down, 10, 9, 8, 7. So that's why it makes a negative scatter plot, because x's are going up, y's are going down. The third kind, which we'll do this one in neon, whatever color that is no relationship. Okay? So with a no relationship, you've got two sets of data that have absolutely nothing to do with each other. So when that happens, your scatter plot is, for lack of a better word, scattered. Okay? All your points are all over the place. You can't tell if they're positive or negative because they're not positive or negative. All right? They're two pieces of information that have absolutely nothing to do with each other. So some situations that could create a positive scatter plot. So like let's say x is the daily rainfall amount and y is the level of a pond. You know, so something easy like that. A negative scatter plot could be, hours spent exercising on the bottom and your starting weight on the left. All right, like or your monthly weight, I guess, on the left. As you know, your time spent exercising goes up, your weight goes down. So just stuff like that. Whereas with a no relationship, you're looking at someone's, a person's eye color versus a person's hair color. One's not really going to have an effect on the other. So there are some examples of positive, negative, and no relationship, or as the book calls it, no correlation. All right. I always taught it as relationship, but the book says correlation. Tomato, tomato, you're just splitting hairs. They're the same thing. Okay, so let's look at some other examples I put in. So we'll start with a positive relationship, okay? So with this positive relationship, you've got average temperature change from January to June. So we know from, living that January to June, the temperature each month is going to go up. So that's why on the graph, we've got, it going up to the right, like that, okay? So as the x values go up, the y values also go up. So that's why it makes that type of scatter plot, positive correlation, okay? Then let's go to a negative relationship or a negative correlation, okay? So altitude on a mountain hike and air pressure in a tire. I put this one in here because in years past this one gave students a lot of trouble. So the idea is that as you increase your altitude, increase your altitude, that your air pressure is going to decrease. And there's a couple of reasons for that. For one, it's colder. Cold air makes air particles slow down. And when air particles slow down, they don't generate as much pressure from friction. So that's why, as you go up in altitude, temperature goes down, air pressure goes down. Or, there's also, there's not as much air to breathe as you get higher up because there's not as much air particles. So if there's not as much air particles, there's not as much air pressure. So a couple of variables going into that. But one thing to note, notice how on the y-axis, the numbers are still increasing by 5. These numbers are not what you look at to see if it's negative or not. You look at your scatter plot. You look at your actual plotted data over here in the field, and then that will tell you if it's negative or not. And then the last one is the no relationship or the no correlation. I initially put a person's weight, but I lost track of what I was doing. So what I went with instead was height. So it's a person's height and their eye color. All right. As you can see, you know, you can't say that if a person has blue eyes, they're a giant, because there's no data to support that. All right. So that's everything that we covered on Wednesday. I really, really hope that this time the volume or the audio quality is at least passable. I'm still working out some snafus with my equipment that I used to record with, but the stuff that I recorded yesterday was unusable. So remember, no lab due this weekend. The labs will open up on Monday, and we'll go back through this again one more time before we start talking about probability. Thanks.